Hey, my name's Avery, and in this video we're going to be doing integration by parts and integration using U substitution with Pythagorean identities. So this first problem is integration by parts, and we're trying to find the integral of 4 plus e to the 5x over e to the 3x. And my first step with the division problem is to rewrite the denominator as a multiple with a negative exponent. So I have 4 plus e to the 5x times e to the negative 3x. And our formula for this says that the integral of u times dv equals uv minus the integral of v times du. And right here I have u being 4 plus e to the 5x, and that would leave our dv to be e to the negative 3x. The derivative of u is going to be 5e to the 5x dx, and then the antiderivative of dv, to help us find our v, is going to be negative 1/3 e to the negative 3x. So really all that's left here to do is to plug in and simplify. I didn't rewrite the problem over here. I just went straight into the solution. So I've got u times v. So 4 plus e to the 5x times negative 1/3 e to the negative 3x minus the integral of v times du. So the integral of negative 1/3 e to the negative 3x times 5e to the 5x. You can simplify those two terms together, and it's going to give you negative 5/3 e to the 2x. And the integral of that is going to be negative 5/6 e to the 2x, because your e is going to stay the same regardless with that exponent. You just have to multiply. So right here we have a 2, so we're going to multiply by 1/2 times our pre-existing negative 5/3, giving us negative 5/6 e to the 2x. And then you're just going to bring it all down, and you have to be careful with this subtraction sign because this is a negative number. So right here you're going to get an addition sign in your final answer. You're going to get negative 4 plus e to the 5x over 3 to the 3x. And sorry, I forgot to mention, but all I did here was just combine these two terms to get that. And then you're having plus 5e to the 2x over 6 plus. Here we have another integration by parts problem. I know my paper looks crazy because I spaced it really weird. But anyways, our number 2, we're trying to find the integral of 3x times e to the 7x. Same thing here. Our u is going to equal 3x, because if we use Lipit, p stands for polynomial, and that comes before e, meaning exponents. So our u is going to equal 3x, and our dv is going to equal our other term, e to the 7x. The derivative of u is just 3, and then the antiderivative of dv is going to be 1/7 e to the 7x. Same thing, you're just going to plug in from this formula I've got up here. So u times v is 3x times 1/7 e to the 7x minus the integral of v du, which is going to be your 1/7x e to the 7x times 3. Same thing, I just combine these like terms. So I've got 3x e to the 7x. Sorry, the way I wrote it makes it look kind of complicated, but the e does go on top. So you've got 3x e to the 7x over 7 minus the integral of 3/7 e to the 7x. And same thing, like I said, your e to the 7x is going to stay the same. You just have to multiply by 1/7 here. So if you do 3/7 times 1/7, you're going to get 3 over 49 e to the 7x, and that is your integral for that part. So your final answer is going to be 3x e to the 7x over 7 minus 3 e to the 7x over 49 plus. And with our final problem, we're going to be doing some trig integrals using Pythagorean identities in our substitution. So we're trying to find the integral of sine to the 7th x times cosine to the 3rd x. And here I'm bringing down my sine, but then I'm going to break up this cosine to the 3rd into cosine squared x times cosine x. And we know that because of one of our Pythagorean identities, that cosine squared x is equal to 1 minus sine x. So if we come over here, again, sorry, I know it's spaced really oddly, but we're going to do u substitution with our u being sine x and our du being cosine x. And so if you rewrite what I just said, sine to the 7th times 1 minus sine squared times cosine, you are going to get u to the 7th times 1 minus u squared du, which is going to simplify to u to the 7th minus u to the 9th du. And you can do that distribution right here instead of waiting to do it with the u. So here it would just be sine to the 7th minus sine to the 9th, and either way it's going to turn into that u formula. and then you're just going to find the integral of that. So you're going to have u to the 8th over 8, or 1/8 times u to the 8th, minus u to the 10th over 10, and then you just plug back in your u, which was sine x. So you're going to have sine to the 8x over 8 minus sine to the 10x over 10 plus c, and that's going to be your final answer.